Hi folks, been a minute. Been really busy trying to get some of the stuff I have previously repaired sold, trying to clean up some of the shelves here. Actually, I did a pretty decent job. If you look on the other side of the garage here, you can see there's shelf space. I haven't seen that in years. But anyway, let's get back to the reason for this video. I have a friend who I met on the Popular Audio Forum, of which we are both members of. His name's Steve, and Steve drops me off a few pieces on occasion. Steve's very cool. He drops off a few pieces, tell me what the problems are, calls me a few months later, got anything ready. So it's kind of a no pressure thing, but I always try to work on other people's stuff first, which means that Luxman is still on the shelf. And for those of you who are wondering if I'm avoiding it, I absolutely am. And I have some videos shot I need to edit just to show you where I'm at with it and what my frustrations are. But anyway, moving to the case on my bench right now, I have a McIntosh C31V preamp. When Steve brought it by, he said it's got electronic volume control. It has buttons for up and down instead of the usual potentiometers that we're used to. And he says the volume control is not working. And I'm going to go over this. It's working now, so I can't show you what the malfunction was, but it's something that's common not just to this, but in fact to a lot of different things, and I'm going to talk about that. But let's take a look at it, and I'll talk about the circuit and what my troubleshooting steps were, okay? So let's take a good look. Okay, so this is the unit. It's currently powered on, and this window right here has a LED bar graph that goes up and down with the volumes, and the volume buttons are here, volume up, volume down. And when we press the volume up, the bar graph increments, our output goes up. We press it down, it goes down. It was not doing this before. It would show maybe half of the bars. You might get another one illuminate, but it was real hit or miss. So the first thing I wanted to eliminate was a possibility that there's a problem with the buttons themselves. And it's not unusual to have buttons that will fail, sometimes open, sometimes short. These are mechanical buttons, they're not the membrane type. So what I did was, these buttons are on their own little printed circuit board with a connector on the back. So I pulled it off. Steve said he had forgotten to bring the remote that he got with it, but this is one of the reasons I really held off on updating my old Android phone, because it had this great app on there called Quick Remote and had an IR blaster on it. I finally had to bite the bullet and get another phone because it was running Android 8 and they're up to 13 or 14. But anyway, turning on my old phone now, which I kept just for occasions like this. And I'm going to fire up that remote. Don't know if you can see this at all, but it says McIntosh and it controls the remote. So what I did was I unplugged the PCB with the switches just so I could try this out. And as you can see, everything works fine. So now I want to talk about the circuit and what the differences are, because anytime you have something that works with the remote, it's a whole order of magnitude more complicated than the circuits we're used to if we work on vintage audio. So let me get the schematics up here. We'll talk about the circuit and I'll talk about tracing through the schematic. Okay, so this is an overall schematic of the control part of the preamp here. And what I want to draw your attention to is it's almost impossible to read anything off of this, at least for me. So I blew up this small section down here in the corner. And that is where our volume up-down switches come into here. And you see where these all say 5? These are on that small printed circuit board the buttons are actually mounted on. So you have a ground, you have a volume up switch, a volume down switch. And basically what we're doing is we are grounding this 5.6 volts that's going into these NOR gates. I want to talk very, very briefly about logic gates. They fall into 3 major categories, which would be AND, OR, and NOT. And an AND gate will have 3 terminals. It'll have an A and a B and an out. Now some have more than 2, but most of them will have 2. And on an AND gate, when A is high and B is high, the output will be high. OR gate, if A is high or B is high, the output is high. And the NOT gate is simply an inverter. If it's high at the in, it's low at the out, and vice versa. These are NOR gates, which are basically just OR gates with an inverter on the end, and that's the easiest way to think about them. So basically, you'll have 0 volts here until you have 0 volts at all of these. And that happens when we ground one of these, or when the remote takes the 5.6 volts off from the microcontroller. So anyway, our voltages go in here and they come out of here and they go to page 8. So let's take a look at page 8. And this is a section of page 8. The volume controls come in here, and I clipped those off when I made this copy, but this is where they come in. You see where you have a 6 in this diamond shape? That's the number of the page. So this is coming from 6, and it's going to this, which is 8. I believe it's 8A because there's an 8A and 8B. But if we look here, it just says 8. So we go to page 8 and we find our volume controls are coming up into here. And sure enough, these transistors are marked volume down switch, volume up switch. And I was able to check at the collector here and here and actuate the switches and see our voltages. And when you turn this on, you get a voltage here or you get a voltage here. I believe there's negative voltages coming in at the emitters. And they go to this electronic volume control IC. So it looked like everything was good going into the IC. But, and this is what I want to talk about, and this is what I found, and this is what bit me even though I had experience with this in the past. So I'm going to stop the camera and we're going to take a close look down inside the unit. Okay, so looking down in this unit, you'll see all the integrated circuits down here, all the op amps and our electronic volume control are all socketed. And sockets are always a trade-off between convenience and reliability. And I've had this happen to me in the past where I thought I had a bad IC, and when I took it out of the socket and put it back in, it was fine because something causes problems between the pins in the socket. I don't know if it's corrosion, electrolysis, dissimilar metals. I don't know what the problem is, but an IC that's been socketed for decades, as these have, can be problematic simply because of that issue happening between the pins in the sockets. Again, I don't know the exact mechanics. There's a guy named that goes by Retrovert on the audio forum I'm a member of, and he is one smart freaking guy. He'd probably know what that is. But anyway, I remember the first time I learned about something like this was when a guy sold me a Fender Mustang guitar when I was a kid. And he said both the pickups are bad. And I just thought it was odd that they'd both be bad. One or the other, maybe both of them, just seemed like a little too much of a coincidence. So sure enough, as I looked at it, the problem was that something had built up on the guitar jack where you plug the cord in. And even though I could see it making contact, my ohm meter showed no continuity between here and here. That's crazy. I could see it touching it. So on a hunch, I took a piece of steel wool and just brushed the tang off on the jack, plugged the cord back in, the guitar worked fine. Got a good deal on that. And that was the first time I'd come across anything like that. So anyway, I said, oh, let me try rocking it in the socket, pull it out, put it back in several times. Still didn't work. I ordered a chip, put it in. It didn't work. I took it out and I put a little deoxit on the pins in the socket. I put the new IC back in. It worked fine. And I thought, let me put the old one back in. And guess what? It worked fine as well. So the problem was corrosion or something in the socket. And this is not the first time I come across this, but this is the worst instance of it I've ever seen, and I have no explanation of why that would be. But this is also an effect that can happen with the interconnects on your stereo, maybe from your CD player to your preamp, integrated amp or receiver. And every once in a while, you just got to give those RCA connectors a twist. And you'd be shocked sometimes at the difference in sound quality. I believe that's why some people buy interconnects and think, oh my God, these sound so much better than the old ones, when all they've done is just break that bad connection. Like I said, just give them a twist every once in a while. It doesn't take long, but something happens. I don't know if it's a form of electrolysis or what, but that's what the problem with this was. And now I have the original IC back in, and you saw that the volume control works fine. So anyway, I'm just going to wrap this video up now. I wanted to talk about this effect. I wanted to talk about how to go through the schematics and trace from one sheet to another, find out where your problem is. So anyway, I thank everyone for watching, and as always, I like giving back to the community that's given me so much. Thanks a lot, folks.